Hi sir, myself T. Kaushik Reddy from CSCB. My roll number is 70 and my topic in Python Tech Talk is memory management in Python. So let's start. So what is Python? So we'll take a look at at the definition of the Python and the basics of the Python. Let us know what is Python exactly. What does it mean? So Python is an interpreted object-oriented high-level programming language with dynamic semantics. It's high-level built-in data structures combined with dynamic typing and dynamic binding. Make it very attractive for rapid application development, as well as for users scripting or glue language to connect existing components together. Python's simple, easy to learn syntax emphasizes readability and therefore reduces the cost of program maintenance. Python supports modules and packages, which encourages program modularity and code reuse. The Python interpreter and the extensive standard library are available in sources or binary form without charge for all major platforms and can be freely distributed. So according to me, the basic what does Python mean is which makes easier what we'll say interaction between a human and a computer. Easy way of interacting with computer uh, with my Python makes easy way of interacting with the computer. That's a basic what is Python is. Who invented Python? So Python is invented by Guido van Rossum, began working on Python in late 1980s as a successor to the ABC programming language and first released it in 1991 as Python 0.90. Python 2.0 was released in 2000 and introduced new features such as list, comprehensions, cycle detecting, garbage collection, reference counting, and Unicode support. Python 3.0 released in 2008 was a major revision that is not completely backward compatible with earlier versions. Python 2 was discontinued with version 2.7.18 in 2020. So, what are key features of Python? That means, what are the uses of Python? Easy to learn and readable language. Python is extremely easy to learn. Highly interpreted language, dynamically typed language, open source and free, large standard library, high-level language, object-oriented programming language, large community support. And another feature I wanted to add in the key features of Python is it makes easy interaction with the computer. So what is memory management in the Python? Memory management in Python involves a private heap containing all Python objects and data structures. The management of this private heap is ensured internally by the Python memory manager. The Python memory manager has different components which deal with various dynamic storage management aspects like sharing, segmentation, relocation, or cache. At the lowest level, a raw memory allocator ensures that there is enough room in the private heap for storing all Python related data by interacting with the memory manager of the operating system. On the top of the raw memory allocator, several object-specific allocators operate on the same heap and implement distinct memory management policies adapted to the peculiarities of every object type. Peculiar, peculiarities of every object type. For example, integer objects are managed differently within the heap than stringly tuples or dictionaries. because integers imply different storage requirements and speed or space trade-offs. It is important to understand that the management of the Python heap is performed by the interpreter itself, and that the user has no control over it. And even if they regularly manipulate object pointers to memory blocks inside that heap, the allocation of heap space for Python objects in other internal buffers is performed on the demand by the Python memory manager to the Python or CAPI functions listed in this document. So to avoid memory corruption, extension writers should never try to operate on Python objects with the function exported by the C library malloc, calloc, realloc, and free. This will result in mixed calls between the C allocator and the Python memory manager with fatal consequences because they implement different algorithms and operate on different heaps. However, one may safely allocate and release memory blocks and with the C library allocator for individual purposes as shown in the following example. So we have an example for this memory management in the Python. This is a code basically py object star res char star buf is equal to char malloc buff sys slash star for I slash o. If buf is equal to null, return Python error underscore no memory. Do some IO operation involving buf. Rest is equal to py bytes from string buffer. Free buff slash semicolon slash star malloc ed star slash return rest. This is the example for the to avoid a memory corruption extension writer should never try to operate this one. For this, it's an example. Allocated domains and allocating functions belong to one of three domains. See, also pymem allocated domain, Python memory allocated domain. These domains represent different allocation strategies and are optimized for different purposes. The specific details on how every domain allocates memory or what internal function each domain calls is considered and implementation detail. But for debugging purposes, a simplified table can be found at here. There is no hard requirement to use the memory returned by the allocation functions belonging to a given domain for only the purposes hinted by the domain. Although this is a recommended practice, allocated domains. So we have three allocation domains. The three allocation domains are, the first one is drawn domain, intended for allocating memory for a general purpose memory buffers where the allocation has to go to the system allocator or where the allocator can operate without the memory is requested directly to the system. Basically, the role domain is used for transferring memory or basically requesting directly into the system without any going to any other files or something. So next one is memory domain, intended for allocating memory for Python buffers and general purpose memory buffers, where the allocation must be performed with the GIL help. The memory is taken from the Python private heap. Basically, what is memory domain is, here we use a GIL held. Allocation must be performed with the GIL held. The memory is taken from the Python private heap. So basically the memory is taken from the Python private heap, and we use a GIL held memory allocation. Object domain, intended for allocating memory belonging to Python objects, The memory is taken from the Python private heap. So object domain is nothing but here the memory is taken from the private heap of the Python, taken from the Python private heap, intended for or allocating memory belonging to the Python objects. So ROM memory interface. The following function sets are wrappers to the system allocator. These functions are thread safe. The guild doesn't not need to be held. The default ROM memory allocator uses the following functions. So the default ROM memory allocator in the Python or memory management in the Python uses malloc, calloc, realloc, and free call malloc or calloc when requesting 0 bytes. So garbage collection. Garbage collection. So we already saw this heading of garbage collection in the previous slide or at the starting of the PowerPoint presentation. So garbage collection is a process in which the interpreter frees up the memory when not in use to make it available for other objects. Assume a case where no reference is pointing to an object in memory. That is, it is not in use, so the virtual machine has a garbage collector that automatically deletes that objects from the heap memory. So garbage collection is nothing but the unwanted or unnecessary things are deleted or detected by the detected by the system is or detected by the system and gets deleted object from the heap memory. So next, reference counting. Reference counting works by counting the number of times an object is referenced by other objects. Nothing but what is reference counting? Nothing but reference counting works by counting number of times an object is identified by the other objects in the system. When references to an object are removed, the reference count for the object is decremented. So when the references to an object when references to the objects are removed, then the object is decremented, nothing but deleted or something like that. When the reference count becomes 0, the object is delocated. Nothing. I don't know exactly the meaning of that. Yeah. When the reference count becomes 0, the object is delocated. Memory allocation in Python. There are two parts of memory in the memory allocation in Python. There are two types of memory: stack memory, and heap memory. So first, the methods or method calls at the difference are stored in. So what is stack memory? The methods or method calls and references are stored in stack memory, and all the values objects are stored. So the methods or method calls and the method or method calls and references are stored in the stack memory, and all the values objects are stored in the heap memory. So these are the difference between the stack and the heap memory. Nothing but stack memory stores method and method calls and the references in it, and heap memory stores the object values. So work of stack memory. The allocation happens on contiguous blocks of memory. We call it stack memory allocation because the allocation happens in the function called stack. The size of memory to be allocated is known to the compiler, and whenever a function is called, its variables get memory allocated on the stack. So work of stack memory, nothing but the allocation happens on contiguous blocks of memory. We call it stack memory, nothing but the size of memory to be allowed is known to the compiler, and whenever a function is called, its variables gets memory allocated on the stack. It is a memory that is only needed inside a particular function or method call. When a function is called, it is added onto the programs called stack. Any local memory assignments such as variable initializations inside the particular functions are stored temporarily on the function called stack. where it is deleted once the function returns and the call stack moves on to the next task. This allocations onto a contiguous block of memory is handled by the compiler using predefined routines, and developers do not need to worry about it. Work of heap memory. How nothing but how heap memory works. The memory is allocated during the execution of instructions written by programmers. Note that the name heap has nothing to do with the heap data structure. It is called heap because it is a pile of memory space available to programmers to allocate it or deallocate. The variables are needed outside of method or functions calls or are shared within multiple functions globally are stored in heap memory. So heap memory has nothing to do with the heap data structure. It is called heap data structure, but it is called heap because it is a pile of memory space available to programmers to allocate or deallocate. So yeah, this is the memory management in Python. Thank you.